Welcome everyone to Module 2, Lesson 4, where we are exploring integrative analysis strategies. In many research projects, we tend to treat our different data sources as separate entities, analyzing the quantitative numbers in one silo and the qualitative narratives in another. But today we are moving from those separate streams toward a unified understanding. The goal of this session is to provide you with the pedagogical tools to bridge that gap, ensuring that your final analysis is not just a collection of disparate parts, but a cohesive whole that reveals insights invisible to any single method. Let's look at our roadmap for this session by reviewing our 4 primary learning objectives. First, we will tackle mixed methods integration, where you will master the specific techniques for weaving together quantitative and qualitative insights into a single narrative. Second, we will explore multi-paradigm analysis, which involves applying different analytical lenses, such as positivism or interpretivism, to reveal diverse dimensions of the truth within the same dataset. Third, we will discuss systems-level synthesis, guiding you to build a coherent understanding from complex, interconnected data streams. And finally, we will cover iterative refinement, helping you develop recursive analytical cycles that deepen your understanding over time. To understand how we integrate data, we must first recognize that integration exists on a spectrum ranging from isolation to full unification. On the far left, we have parallel analysis, the least complex approach, where you run separate tracks with independent methods and simply present the results side by side. Moving inward, we see sequential integration, a building phase where one method informs the next to provide progressive depth. Next is convergent synthesis, where we actively merge streams for joint interpretation to create meta-inferences. Finally, on the far right, we reach the most complex stage, fully integrated analysis, where we use a unified framework with seamless weaving to generate emergent insights that wouldn't exist if the data were kept apart. Now let's discuss the mechanics of integration using joint display techniques. There are 4 core approaches: side-by-side displays for parallel comparison, data transformation, where we convert text to numbers or vice versa, matrix integration for mapping cases against themes, and visual mapping for layered patterns. Let's look closely at the integration matrix example on the slide to see this in action. Under the theme of access, the quantitative data shows 78% report barriers, giving us the magnitude, while the qualitative insight explains the mechanism. The system feels designed to exclude us. Under trust, a low mean score of 2.3 explains the what, while the quote, past experiences shape current fears, explains the why. This matrix proves that while numbers reveal the magnitude, stories reveal the mechanism. Beyond just mixing data types, we must also mix our mental models using the multi-paradigm analysis framework. This involves taking the same data and looking at it through multiple lenses to gain a richer understanding. First, apply the positivist lens to focus on causality, statistical significance, and generalizability. Next, switch to the critical lens to ask about power dynamics. Whose voices are missing, and what are the structural barriers? Then, use the interpretivist lens to focus on meaning, lived realities, and context. Finally, use the pragmatist lens to focus on solutions, asking what works and what are the consequences. By rotating these lenses, you ensure your integration reveals the full picture rather than just one angle. Integration is not a one-time event, it is a loop that we call recursive analysis cycles. The process begins with initial analysis, a first pass through the data using your primary lens. Step 2 is the cross-check, where you compare those findings with alternative methods or paradigms. Step 3 is integration, where you synthesize findings and, crucially, note any tensions or disagreements. Step 4 is refinement, where you return to the data with deeper questions and repeat the cycle. As you move through these stages, remember to embrace contradiction, because tensions reveal complexity. Document the evolution of your thoughts. Question your assumptions at every turn, and seek saturation by stopping only when your insights stabilize. Let's ground this in a real-world case study on environmental health equity, asking the question, what is the impact of air pollution on maternal health in marginalized communities? If we looked only at the quantitative data, we would see that a 10 microgram increase in PM 2.5 correlates with an 8% increased risk. That is valuable, but incomplete. If we add the qualitative stream, we hear community voices revealing a theme of can't move away. Then, adding a spatial lens via GIS mapping reveals highway clusters and justice zones. By weaving these three streams together, the result is a complete picture showing that we need both high-level policy changes and community-based solutions to truly address the problem. To execute this kind of complex analysis, you need the right software, and your choice depends on your team's skills and budget. MCHES is often considered the mixed methods champion, with built-in joint displays for stats and qualitative data. Deduce is excellent for web-based collaboration and mixed data matrices. If you have coding skills, R or Python allow for custom integration scripts and reproducible workflows. NVivo is powerful for framework matrices, while Atlas.ti excels at network visualizations. For the final presentation, Tableau or Power BI provide interactive dashboards. Regardless of the tool, remember to use CSVS for export/import and always version control your analysis. I want to be realistic. Integration is difficult and you will face challenges. You might encounter a paradigm clash. When this happens, use a dialectical approach to find synthesis. You might struggle with weight and priority. Let your research questions decide which data stream leads. You might face timing misalignment. The fix is to build integration points early in the design. If you have team expertise gaps, create transdisciplinary teams where skills complement each other. For representation issues, layer your visualizations to show depth. And for validity concerns, use an integrated validity framework. Remember, these challenges aren't failures. They simply reveal the complexity of the subject we are studying. As we conclude, here are your immediate next steps. First, map your methods by identifying all your data types. Second, design integration points. Don't wait for the end, plan exactly when streams will connect. Third, create joint displays to visualize those connections. Fourth, practice recursion by returning to your data with new insights. And fifth, share and refine your findings. Remember the quote at the bottom of the slide, "The magic lies in productive tensions when worlds collide." Embrace the complexity, seek coherence, and honor the diversity of your data to move from simple analysis to unified understanding. Thank you for your time.